if we're trying to find missing pieces of a triangle, again, we're talking about right triangles. So we're going to draw a right triangle. This tablet that I'm using is not the greatest, so bear with me here. When we're trying to draw a right triangle, again, we're using these Greek letters. So that's not a lowercase a, that's an alpha. So we'll see, and this is going to look really bad. That's going to be my alpha. That's terrible. And then this will be a. And the other angle measure that goes with B is going to be a beta, which kind of looks like that. In geometry, you would have just used like a capital A and a lowercase a capital B and a lowercase b, and that's okay if you want to stick with that. The variable itself is not as important as knowing how to do it. Um, so we know that this angle up here is 20 degrees, and we know that this side length over here is 12.3. So we want to find all of these missing pieces. Okay, so easiest, well, actually, before I get into that, let's make a list of everything that we need to find so that we know when we're done. So we have A, B, and C for our side lengths. And then we have alpha and beta. We already know that C, gamma would be the next letter, but we already know that that's 90 degrees because we're told it's a right triangle. So we need to find these other pieces. All right. Easiest thing to do first is find beta because I know that this angle alpha is 20 degrees and this is 90 degrees, right? So beta has to be 70 degrees because, like we talked about yesterday, the inside angles of your triangle have to add up to 180. So, yeah, that's, you just subtract them from 180. So you would just do 180 minus 90 for this right angle, and then minus 20 for alpha, and that'll leave you with 70. We already know that alpha is 20. Excuse me. And we know that B is 12.3. So we only have to find one other piece, and then what we'll do is use Pythagorean theorem to find the third piece. So let's say if I want to find beta, I want to find this angle down here. We always want to use information that we know that we're given in the problem because we could have made a mistake to find one of these angles. So actually, I highlighted the wrong part. I'm going to find this A, this side length A. I already know beta is 70. So if I want to find this side length A, again, I know alpha is 20, and I was also given this angle B, or this side length B over here. So I can use that information, all right? So using one of my sine, cosine, or tangent, one of those three trig functions, I know what my adjacent is, and I'm trying to find opposite. So that means tangent, right? Because tangent is opposite over adjacent. So if I set up my equation like I did at the end of the period yesterday, tangent of 20 degrees equals opposite is A over adjacent is 12.3. Okay. Now, again, we have our angle measure in degrees. So if we're looking at our calculator like we did yesterday, we have to change that into degrees. So again, if you're not sure how to do that, let me know. I can explain it to you. I did go over it yesterday, but I know some people weren't there. So, change that into degrees. We want to get A by itself. So that means we have to multiply both sides by 12.3. And we'll do that over here. Multiply by 12.3. That'll cancel these out and just leave us with A by itself over here. So basically, all we have to do is just plug this stuff into our calculator and we'll get our answer. Again, we'll just round it to 3 decimal places. So if you want to try that, you can. I'm just going to plug it in here real quick just so we can move along. I ended up getting A to be approximately equal to 4.47. It's 768, blah, 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 blah. So we're just going to go 77. Okay. And again, think about it. If B is 70 degrees and that produces a side length of 12.3, then this side length of 20, or this angle of 20, should produce a much smaller side length. And we can see that's what we got there. So 4.477. To find our third side length, just like we did, I don't know when you first learned Pythagorean theorem, but if we have two pieces of our, right triangle, we just use Pythagorean theorem to find a third. So A we just found to be approximately, and again we're just going to round this because tangent of 20 is just an approximation. So we're just going to approximate this. We'll have a rounded answer. B, we actually know the exact number because we were given that in the problem. Squared equals c squared. Now, understand this is not the only way to do this. Okay, I think this is just the easiest way because you're more familiar with it. But the other option that we could do, I'm going to finish it out using Pythagorean theorem, but the other option that we have is we can use a trig function. Okay, so we can say, all right, if I know this angle A, or alpha, and I know this piece, which is adjacent, and I'm trying to find the hypotenuse over here, I can use cosine. So we could say cosine of 20 degrees equals adjacent, 12.3, over hypotenuse, which is C. Right, and we did a problem just like that yesterday. You could do it just like this. You'll get the same answer. Your rounded answer may be slightly different, but it'll still be close enough. That's one of the reasons why I go to 3 decimal places, because everybody should be the same at 2 decimal places then. So, but I'm going to use this Pythagorean theorem over here. So, so if you want to plug that in, you can. But like I said, I'm just going to plug it in here real quick. 12.3 squared. Let me take the square root of that. I got 13. Again, this should be our biggest side length, which I got a 13 point something, so we're good there. I got 13.0893, so we're going to say 0.89. Okay, so again, you use some information you know from before, from interior angles adding up to 180, Pythagorean theorem, and then now we're throwing in the trig stuff to help us find those extra pieces. Okay. So, does anybody have any questions on that one? All right. So next up, some word problems. And again, these are all right triangles. So what I would suggest you do to start these problems off is just say, all right, we're going to draw a right triangle somewhere. So, so Kirsten places her surveyor's telescope. Here's the telescope. I'm not going to attempt to draw a telescope because it will look horrible. On top of a 5-foot tripod. Now that is kind of important for this problem. So here's the tripod. And it's important that we know that that tripod is 5 feet above the ground, because we'll have to take that into consideration when we find the overall height of the tree. She measures an 8-degree elevation above the horizontal. So here's our horizontal. Let's pretend that's a perfectly straight line. And there's a tree. Oh, my power just went out, so I'm going to lose service. All right, I'm going to finish this problem out. And anyway, I know my internet went out now, so you can see it's trying to reload there. So I'm just going to finish this problem and I'll upload it later. So here's my tree. We know that she measures an 8-degree elevation to the top of the tree. And again, we are trying to form a right triangle in there. So here's my 8-degree elevation. We know that this tripod is 120 feet away from the tree, and our goal here is to try and find the height of the tree. Now I'm going to put X for this side of the triangle because, like I said before, we have a little piece down here for the tripod that's 5 feet above the ground. Okay, so we have to take that into consideration as well. So again, if I know this angle, excuse me, and I know this piece here, which is my adjacent, and I am trying to find, okay, the piece that I'm looking for is this piece over here, which in relationship to that angle is opposite. All right, so I'm going to say tangent of 8 degrees is opposite, which is X, over adjacent, which is 120. Okay, so that's going to be your setup. Again, tangent of the angle equals opposite over adjacent. From SOHCAHTOA, tangent of your angle equals opposite over adjacent. So we just have to multiply both sides by 120. Again, make sure your calculator is in degrees. These cancel. So plug it in real quick. 120 tan of 8 degrees. I ended up getting 16.8649, so we'll say 865. Now again, that's just the piece of your triangle over here. Okay, that's just the side of the triangle. We have to add 5 to find the height to be 21.865 feet. Okay, so again, you want to make sure you answer the question, put your units in there, make sure you have units, whatever it is, feet, inches, meters, whatever. But again, you want to make sure that you add in your height of the tripod or any extra pieces of the triangle that you need. So, all right, you have a worksheet to work on. Here's the rest of the video. You can watch this and let me know if you have questions.